Okay, Marjorie, we can see your slides. I can
Great.
see you. So go ahead. And again, please introduce yourself as part of the opening. Thank you.
Well, and so can you hear me too?
Yes, perfect.
Okay, great. So I'm Marjorie Freedman. I'm a researcher at ISI's Boston office, and I'm going to talk to you about using Pegasus for natural language processing and machine learning workflows. Jacob, who's here with us today, is going to give the final few slides of this talk, and I'll mostly let Jacob introduce himself, but he's been interning with us for 2 years as an undergraduate and will be joining soon. So we're super excited for that. And has really helped us build this collaboration with the Pegasus team. So our knowledge of Pegasus actually started at ISI's Research Day last year, which was pretty exciting. I had been in the process of trying to coordinate internally over a number of projects that I'm a part of or lead or am aware of, building up our own HPC setup. And trying to think about how we could do repeatable experiments once we had that set up. And so my primary research area is extracting and organizing information, starting out many years ago, really looking at language, and more recently moving into a lot of work where I have collaborations with people who do vision, and so looking at multimedia sources as well. And so even a little bit more broadly than that, can we automatically understand human communication? And if we do that, can we develop tools that make use of the communication? There are some pretty general workflows here. So we're training and testing models. We want to train a bunch of different versions of these models with different parameters or different training data or different amounts of data, and test them and then measure their performance on some test set. We also tend to be pipelining a lot of different components. So as an example, if you take broadcast news in a non-English language and you want to transform that into a database of what meetings happened when and who attended them, you need speech recognition. You might want machine translation. You might want to do named entity recognition. You need to identify those meetings. You need to know who attended the meetings, where the meetings were, and so that's an event entity relation. And then if you're also paying attention to the video, you're going to need to do information kind of recognizing those landmarks, those people in the videos. And so we use HPC to do this, to process mini files quickly, often independently. So these tend to be embarrassingly parallel workflows. Some of what I do looks at, can we build knowledge bases across many different documents? And so then you have dependencies in your processing over a large data set. But a lot of times I'm looking at a single newswire article. It's 500 words and 1 or 2 pictures, or a single 5-minute video clip. And each of those can be treated independently. And of course, we're doing machine learning grid search because we're trying to optimize these models. So why were we interested in Pegasus? So we'd set up a cluster using Slurm, but we have these common workflows that need to be rerun often. And so automating the steps, that the workflow makes it easier. It's really important to me that we're building pipelines that are replicable, that we have a record of what we did. We're reporting our results. It's frustrating to us when we can't replicate other people's results. And so we want to be sure that we have a record of, what parameter we used, and a workflow lets us do that. And in our particular case, we've set up our HP setup in a way, we have a kind of interesting fusion of a condo model and sharing, where you can use the most machines if you keep your job short. And so this leads checkpointing to be critically important to us, because if you can keep things under 45 minutes, you have a guarantee of being able to use shared resources. And so what we've done, and Jacob's going to talk about this more, is a wrapper to make it easier for us to use Pegasus. Before Jacob talks about the specific wrapper, I just thought I'd give you 3 examples of the workflows. So one is fine-tuning pre-trained language models for leaderboards. If any of you are following NLP progress over the last 5 years, there's been a growing number of mega benchmarks. And so the Allen Institute is where I've screen captured these images from, has probably 20 plus different multiple choice tests that are designed to test different aspects of how one's models do a good job at understanding data. They often have this shared structure. So they might be true, false, or multiple choice questions, or short answer generation. And we'll have things that we want to look at. So what is the relationship between accuracy and size of the test set specific training data as opposed to general purpose training data? Also, we might want to optimize parameters for a particular condition. And with these neural models, much of the time that is just a search, trying to find which hyperparameters work best. You can't expect those hyperparameters to be independent of your training data size. So your learning rate is probably going to have some relationship to how much you are learning from. And so we want a simple setup, run many times, where we train a model at some training data sample with some set of parameters, run inference over that development data to give us a sense of how we're doing, and then score. Then we might want to ensemble these models because ensembling frequently improves performance, and see, does it actually improve performance? Voting doesn't always help. And then aggregate into a table. And so it's a pretty simple workflow, but one that we really want to be repeatable because there are so many little details to check. So that's one example for us. Another example that Jacob will be presenting next is very familiar with is a project we have called Adam on learning in a childlike manner to map simulated perceptual inputs or outputs, depending on which part of the system you're thinking of, into language. So can you learn like a child to differentiate between cookies and Frisbees? And we have curriculums that try to teach the learner this. Our primary research isn't in graph matching. We recognize that this is a hard problem, but we're really focused on how the features of learning impact us. And so our graph matching is slow. But as I've already said, our cluster is set up to provide access to more nodes if every job is under an hour. And so here, what we want to do is parallelize at the curriculum level, but be very sure that we save regularly and checkpoint such that when we get interrupted, we can still finish a curriculum. And then finally, so Dan, who's also here, is a part of this project. I have a project where we're trying to do this massive amount of multimedia data processing. And this is a simplified system diagram of what it looks like to go from a YouTube video or a newspaper article or Twitter all the way through this process. And so you'll notice that the type of data that you're looking at sometimes impacts what model you want to use. And so you want to use English OCR if you have an English document, and if it's a Russian document, the character set is entirely different. You need a different model. Some of these pieces, so a lot of this is a collaboration with several universities, and within a university, you might have 4 or 5 different models that are doing different things. And I haven't, that's why I call it a simplified diagram. I haven't tried to pull out all of those pieces. The models are static. So in this case, we aren't trying to do any of the learning. But we are trying to do the application. Each document can be processed independently. And so can speed things up a lot if we can split at the document level and repeat this pretty messy graph many times. Different processing, as I already said, applies to different documents. We're doing really simple connections between these. So we're writing to shared storage and reading from shared storage. And an individual researcher is likely only working on one component in this graph. So we might have one person who's working on landmark linking. And that person, we want to encourage to let us know when something changes, because they might break everything. And so we'd really like a way to save some of this state and restart from any place. And so Dan right now is actually working on getting all of these pieces to run together with the Dockers that we've been given. So with that, I'm going to turn things over to Jacob to talk about the wrapper that we've done to help us with some of this.
Yes, as Marjorie mentioned earlier, I've knocked the wire from my camera. As Marjorie mentioned earlier, I've worked for part-time with ISI for the past years, and one of my focuses while I've been working there has been on this VISTA Pegasus wrapper. So what the wrapper aims to provide is an easy way for our researchers to set up Pegasus workflows without needing to understand how to configure the sites catalog or partition access on the cluster. And so we've simplified all of that into individual function calls. So you can set up a workflow that automatically builds all the associated Pegasus dependencies to run on the cluster availability. And then you can request a Python job and provide easy use for using Conda. Then you can ask for resource request using a parameterized model so that you don't have to be able to be familiar with every single detail every time if you're not worried about it. We provide a lot of defaults in that regard. We also automatically generate the bash script that would be required to submit the Pegasus job and take care of some amount of automatic checkpointing by providing our own little file system markers that a job has been completed, so that if somebody using our cluster is already using a designated location on the file service, they didn't have to rework their workflow into passing in the correct inputs and outputs into Pegasus when that's already taken care of in a parameters file. So this wrapper sort of cheats in a way at Pegasus file management system so that we can use data reuse in a sufficient manner without having to have researchers modify their workflows. You can go on to the next slide. And then why did we want this VISTA Pegasus wrapper? We wanted to abstract on top of Pegasus abstractions for workflows so that a researcher who's unfamiliar with the transformation catalog or the sites catalog doesn't have to be worried about those details of the Pegasus layer, and they're automatically taken care of by this wrapper. We also, as I mentioned, create this automatic checkpoint files so that data reuse is simpler for somebody using a parameters file with fixed locations on our shared NAS rather than rebuilding that appropriate data structure into the Pegasus workflow. It also handles our Slurm resource requests so that you can correctly request the correct resources so that, as Marjorie mentioned, you can get those short jobs done in a reasonable manner. This wrapper doesn't require existing Python scripts to change because a lot of the researchers already had stuff developed with those parameters files. But future work goals are adapting these parameter files into using the correct file management within Pegasus so that we could start using non-SAGA or non-shared file system resources. So if some research needed to use AWS or Google Cloud application or even the Open Science Grid, they'd be able to handle data transfers automatically with Pegasus in the near future.